All right. I think I am set up mostly. Let me turn this down a little bit. I guess it's fine. All right. So today I will be working on my library more. Cancel. My library CL-PERMUTATION, which is a library that deals with permutations. Permutations and permutation groups, I guess. So a lot of the content here is going to be mostly mathematical in nature, I guess. As a little disclaimer, I have an idea of what I want to program for this. I have no idea how I'm going to program it. It's just going to be programming as if I was writing code naturally, I guess. So yeah, that's it. I hear my voice somewhere. I want to fix that. Oh, right here. Okay. So, all right. So what I want to program today is the concept of free groups. I'll give a little explanation of what they are, just so so it's understandable what I'm doing. And then after I program free groups, I'd like to write some code to work with the so-called straight line programs, which is not the same straight line program concept that you may learn in computer science. It actually has to do with permutation groups. So yeah, let's get started. So I'm going to make probably a new file before I load, or actually I'll do it after. No, I'll do it before. The idea of a generic group seems like a sensible thing to program, and then I probably will want something to work with free groups. So I'll hold off on the free group thing for now, and we'll just do a generic code for just groups. So let's do this. Put the normal boilerplate up here. As you guys will see, I'm not really an Emacs expert. I'm not really a math expert, and I'm all right at programming, as I would say, but I don't know if I would characterize myself as an expert. So, okay, so first I want to define a generic notion of a group, and I want to do it in a way that's useful computationally. Just to go over some of the basic characteristics of a group, a group G is a set S along with a binary operation, which I'll call asterisk, such that there exists. So a group is something that just a set of elements. It can be anything, like integers. It can be anything, any set, as long as there's some operation where we can combine elements together to make new elements of a group. So if A and B equals is in S, maybe I should say whatever is closed within S or something like that. So if you take two elements within a group and combine them, you get another element in S. in fact, we don't even need to say set S, we can just say in a group G. There's an identity element, which I'll call E, which is in G, such that the element E times any element in G equals G, which also equals G times any element in E. So that's what that is, and then there's some notion of associativity, kind of flatness of the structure, saying that, you know, A times B times C is equivalent to A times B times C. Anyway, these are all the basic group operations. A group is just something such that it's closed within G, that there's an identity element, and that there's associativity. So for example, the integers with plus is a group, because if we take any two integers, like 2 plus 3, we'll get 5. That's of course an integer. Any integer plus any other integer will produce a new integer. It should be. Let me double check that this is being recorded, if I remember how. Yeah, it says it's being archived. I don't know if there's anything else I need to do. Secondly, addition also has an identity element, 0, because 0 plus any number n equals n, which is the same thing as any number n plus 0. I mean, and then obviously we can add in any order. So, in the context of permutation group theory, the times operation is composition. So I'm tempted to just, when I define the I think I'm going to define a protocol for the group, for the notion of a group, and I'm just going to say that that binary operation, that times, is just composition. So, and by the way, I don't know if you can do full screen. So I'll start with def generic, compose, our group G, and then two elements A and B. Compose. So composition is one thing. I'll want to be able to extract the identity element. So generic identity element. It's kind of wordy, but Lisp already has something called identity, and I don't know if I will want to shadow that or not. So the identity element. I'm not going to define an abstract class, I don't think, because right now I don't really see a use in doing such. So, and because the other reason I don't want to define an abstract class is because there are types and classes that exist already that do satisfy the group property. So, for example, if I had a representation of the additive group of integers, I wouldn't need to, well, I actually would need to make a new class. If I assume that integers were the additive group, then I could define these functions on that, and I wouldn't need to make a new class. So I'll hold off on defining any new class. So I think that's really it. These are the two real defining things of a group. Obviously, without more sophisticated symbolic or computer algebraic facilities, we have to assume that the implementations, the methods on these generic functions satisfy these group laws. That's the same thing in, with monads in Haskell, or, whatever it may be. We could write some tests to verify that these laws are satisfied, but we can't actually encode it in the protocol. with that said, I think this is the, really the only thing that we need in this file. Definition of group protocol. This is worded, G is closed under. One thing to note with groups is that they need not necessarily be commutative, meaning if you have some group, A times B does not necessarily need to equal B times A. It's not necessarily a true statement, but for a lot of the groups that people work with, it is true, and those are called abelian groups. Now we'll want to take this protocol and implement it for the single group that we do have already, which are permutation groups. So we can go to our permutation, and where's this file? I think I put this file in the wrong location. Let me move it to source, my permutation. And the group.lisp to source. So if I go to source permutation group.lisp, I have all these functions. So I can def method. I should compile them real quick. I should start up my Lisp, in fact, before I even do that. Let's keep this kind of small. And actually, let's make the window bigger. By the way, I don't normally program with my editor with this font this big, but I figure it's easier to read, especially if the stream is being compressed. So let's load. Quick load. So we have it loaded, so now I can go into the permutation group and implement this protocol. I guess, I didn't save this. So def method identity element of a group G that is a perm group. The identity element is just the group identity of G. I've already defined that here.